All right, welcome everybody to the first update vlog of my project called Tracing Rays Around Black Holes. This project is all about creating animations and scientifically correct images of black holes and other places where space-time is heavily curved. In order to do this, I am trying to implement as many of the equations of Einstein's theory of gravity into Blender. And the long story short, that is that Einstein's theory tells us that energy and mass curve spacetime, and spacetime in turn determines how things move in space and time. And this tells us that gravity also influences light, even though it has no mass. And then if you know a little bit about Blender, you know a little bit about making images in Blender using a render engine, you know that it's always assumed that light rays travel in straight lines. But in this case, if there is some heavy body or some large collection of energy somewhere curving spacetime, light will not go into straight lines anymore. So actually correctly visualizing these astronomical objects like black holes, we need to write a custom render engine in Blender that takes into account that light travels differently in a curved space than in a flat space. So, after 6 months of work, I have some first results to share with you. What you see on the screen right now is a black hole and a starry background. That is actually all you see. And if I go to this tab, you can also see it move. So here I have animated this black hole in Blender, and it moves from the left to the middle of your screen, and you can see how it warps and lenses the background of the scene. Well, this already looks really cool, but it's actually a very simple scene in Blender. So what this looks like is just this. So what we have is we have a camera right here, and then we have this sphere moving from left to right. Inside this sphere is located is a black hole, and this black hole is about 1/60th of this sphere. So this sphere represents the curved spacetime around the black hole. So outside this sphere, I just used simple normal ray tracing in Blender, so where light travels in straight lines. But inside this sphere, I use general relativity, so Einstein's equations, to calculate how light rays travel in the curved space around the black hole. And that is actually all that the animation shows you. So it's actually really simple as far as the Blender scene goes, but of course there's a lot of math and physics implemented in the ray tracing. And now you can just simply put this black hole into any scene that you like. So here I have 4 spheres, and I shoot them over your head towards and behind the black hole. Well, the spheres, I gave them a nice texture of a moon, so that it looks a little bit nicer. And what you see is that as soon as the spheres get behind and next to the black hole, a lot of stuff is happening. So what does this look like in Blender? So this is just simply this animation. So yeah, 4 spheres moving over this black hole, over and around. But to understand what is happening, so let me just show you a little bit what is happening. So for example, this moon is flying to the side of the black hole and behind, and you can start to see a second image of the same object here to the right of the black hole. For this object, just the same, you have an image here and you have an image here. This is because the lines of sight, there are actually multiple lines of sight ending on the object, giving you 2 images to look at. So if we, for simplicity, just go to a 2-dimensional example, here in the middle in black you see the black hole, And in red, you see multiple light rays being shot around the black hole. So they all start at -15 in the x dimension, and they start at different values in the y direction. And their direction of travel is indicated by the black arrow, so they all travel in the x direction initially. And what you see, due to the curvature of spacetime generated by the black hole, these lines don't travel straight, but they curve around the black hole. And now you see that here I've taken a blue, I've drawn a blue line for a light ray that starts below the black hole. And you see that it crosses all these other lines of sight as well. And this is what creates this double image. So this one to the left would be one of these red lines, and this image here would come from one of these blue lines, creating a double image. And it gets really, really crazy, because if you take light rays that pass very close to the black hole, you see many of them actually end on the black hole, but some of them are deflected by space-time so strongly that some of them even directly go back to the observer. So actually, in some parts of the visualization of the black hole, you can actually see the things that are behind the camera. So that is really quite crazy. And then, of course, you can do all kinds of crazy things. If you have your living room modeled in Blender, you can put a black hole into your living room and see what it looks like when the space in your living room is heavily curved. So here I've shown a very large cosmic Suzanne to the right and the back of this black hole. And you see how the image of Suzanne is distorted and how a second image upside down is created at the other side of the black hole. Well, in this case, I need to increase the sampling a bit, but yeah, you get the idea. Okay, so I am really excited to have this first vlog to give you an update on how far it's going. So there's also a GitHub page if you want to know more. Here you have all the animations, explanations of how it works. You can look at the code, and you can also see what I plan to do in the future, because there's still a lot to do. I have to implement many features, like normal features, into the render engine, materials, lighting, all that stuff. I need to be able to render objects that are inside curved spacetime. That's not possible right now. Of course, I also want to implement that the camera can travel into this area where the spacetime is curved. But yeah, that's a lot of physics that I still need to build in, and I will be working on that in a couple of months, in the next couple of months. All right. Well, thanks for your attention. Thanks. And all the links you can find in the subscription in the below of this video. And well, hope to see you again soon. Cheers.